Good morning, everyone. Today we are going to learn about petroleum geology for drilling exploration. This is a topic 2 in petroleum drilling. The first subtopic we are going to start with is the sedimentary basins. A sedimentary basin is a large depression in the Earth's crust where sediments accumulate over millions of years. These sediments may contain organic matter that can be transformed into oil and natural gas under suitable temperature and pressure conditions. We are going to look about the formation of sedimentary basins. Sedimentary basins form when the Earth's crust subsides due to tectonic processes such as the rifting, the compression, the thermal subsidence, the strike-slip movement. And then we are going to look at importance of sedimentary basins in petroleum exploration. Sedimentary basins provide the essential components of a petroleum system. They include source rocks, the reservoir rocks, the sealed rocks, the traps, and the migration pathways. The source rocks are organic rich shells that generate hydrocarbons. And then the next is the reservoir rocks. These are porous and permeable rocks that store hydrocarbons. And then seals rock are impermeable layers that prevent hydrocarbon escape. And then traps are geological structures that accumulate oil and gas. And then lastly is the migration pathways. These are the routes through which hydrocarbons move from source rock to reservoirs. And then we have main types of sedimentary basins. We have the Rift Basin, and then we have the Foreland Basin. We have the passive margin basins, and then lastly is the intracratonic basin. And then we have the petroleum generation within a sedimentary basin. There is an image or an illustration showing that petroleum system. We have the cap rock, we have the gas, we have the reservoir rock beneath the gas, and then we have the source rock on the bottom, and then we are shown the migration pathways. And then lastly we are going to look on the role of before the role of sedimentary basins. Let's look at the formation of petroleum stages. The first stage is the deposition of organic matter. We have the burial and compaction. We have the maturation. We have the migration. And lastly is the accumulation. So now let's look at the role of sedimentary basins in drilling exploration. Before drilling, geologists evaluate sedimentary basins to determine the presence of source rocks, the reservoir quality, the seal integrity, the trap geometry, the thermal maturity, and lastly the hydrocarbon migration pathways. And then exploration techniques include the geological mapping, the gravity and magnetic surveys, the seismic reflection surveys, the well logging, and the exploratory drilling. And then the next subtopic is the source rocks, reservoirs, and seals and traps. In petroleum geology, hydrocarbons, that is the oil and gas, accumulate only when four essential elements of a petroleum system are present. These are the source rocks, the reservoir rocks, seals, and traps. And then let's now look at the source rocks. Source rock are sedimentary rocks that contain sufficient organic matter from the remains of plants, algae, microorganisms, and then over millions of years, heat and pressure transform this organic matter into oil and natural gas. And then characteristics of this source rock are they rich in organic material, that is they have high total organic carbon, that is the TOC. And then they are usually fine grained rocks such as the shale, the mudstone, the marl. And then they are deposited in low oxygen environments that preserve organic matter. And then we have types of organic matter, that is type 1, type 2, and type 3. Type 1, we have the algae, those are mainly oil. Type 2 is the marine planktonic, that is the oil and gas. Type 3 is the land plants, and they are mainly gases. And then secondly, let's look at the reservoir rocks. Reservoir rocks are porous and permeable rocks that store and transmit hydrocarbons after they migrate from the source rock. The key properties of these reservoir rocks: one, we have the porosity. Porosity is the total volume pore times 100. That is how it is calculated. And the definition of this porosity is the percentage of pore spaces within a rock. And then high porosity means greater hydrocarbon storage capacity. The second property is the permeability. This is the ability of fluids to flow through interconnected pores. High permeability allows oil and gas to move easily. And then we have common reservoir rocks. They include sandstone, limestone, dolomite, fractured shell, fractured basement rock. And then let's now look at the seal rocks or the cap rocks. Seal rocks are impermeable formations that prevent hydrocarbons from escaping to the surface. Characteristics: they are very low permeability, they are continuous and unbroken, and then they are capable for holding hydrocarbons under pressure. And then we have common seal rocks, that is the shell, claystone, evaporites, and dents in limestone. Functions of a seal is they stop upward migration of hydrocarbons, they maintain reservoir pressure, and they enable hydrocarbon accumulation. Now we have two types of seals. One is the regional seal, and secondly is the local seal. The regional seal covers a large geographic area, and the local seal covers a specific reservoir or a trap. And then now let's look at trap. A trap is a geological configuration that allows hydrocarbons to accumulate beneath a seal. Because oil and gas are less dense than water, they migrate upward until trap. And then let's now look at types of these traps. The first type is the structural traps. They are formed by tectonic deformation. And then under these structural traps, we have anticlinal trap. An anticlinal trap accumulate at the crest of a folded rock layer. And then next is the fault trap. This is still under the anticlinal. They are created when the fault juxtapossesses permeable and impermeable rocks. And then second type of a trap is the stratigraphic trap. They are created by changes in rock type or depositional patterns. Examples are the pinch-out traps, the reef traps, the unconformity traps, the channel sand traps. And then we have the combination traps. They are formed by both structural and stratigraphic process. Examples are the faulted anticline and the folded pinch-out reservoir. And then now let's look at the importance of drilling in exploration. Before drilling an exploration well, geologists and geophysicists evaluate the presence of a mature source rock, the quality of a reservoir rock, the integrity of the seal rock, the existence of an effective trap, and then lastly is the timing of hydrocarbon generation and trapping. Now let's look at the structural and the stratigraphic traps. And I think we have already looked at these types of traps in module 2 when we were looking at the source rock and traps. But now I think everything is being repeated. Yeah. The types of stratigraphic, we have the pinch out, unconformity, the reef trap. But let's look at the comparison of structural and stratigraphic traps. Let's look in terms of the formation. Under the formation, structural trap are formed due to tectonic deformation. When we say so, we mean the folding and the faulting. And then the stratigraphic trap is the depositional or erosional changes. Now let's look basing on the main control. In structural trap is the rock structure, and in stratigraphic trap is the rock characteristics and layering. And then now let's look basing on the examples. Examples of structural, we have anticline, we have fault, and we have salt dome. And then stratigraphic, we have the pinch out and conformity reef, among others. Now let's look basing on the detection. On structural trap, they are relatively easier with seismic data, and in stratigraphic trap, they are more challenging and requires a detailed interpretation. And then now let's look on petroleum systems. A petroleum system is the complete set of geological elements and processes necessary for generation, migration, accumulation, and preservation of hydrocarbons, that is the oil and natural gas. And then key elements of a petroleum system. As we've said through module topic 1, 2, and 3, a source rock is a sedimentary rock rich in organic matter that generates hydrocarbons when subjected to sufficient heat and pressure over geological time. Examples, we have the shale, we have the organic rich mudstone. And then the function is to produce oil and gas. Now let's look at the reservoir rock. A reservoir rock is a porous and permeable rock that stores hydrocarbons. Examples are the sandstone, the limestone, and the dolomite. The function is to provide a space for oil and gas accumulation and allows fluid flow. And then we have the seal or the cap rock. A seal is an impermeable rock layer that prevents hydrocarbons from escaping. Examples are the shale salt and dense limestone. The function is to trap hydrocarbons within a reservoir. And then next we have a trap. A trap is a geological structure or stratigraphic feature that accumulates hydrocarbons beneath a seal. Types, we have structural and stratigraphic. The function is concentrates hydrocarbons into economically recoverable accumulation. And then let's now look at the essential process of a petroleum system. The first process is the generation. Organic matter in source rocks is buried and heated, converting it into oil and gas. The second process is the migration. Hydrocarbons move from the source rock through permeable pathways toward a reservoir rock due to buoyancy and pressure differences. And then the third process is the accumulation. Oil and gas collect in reservoir rocks beneath a seal and within a trap. And then fourth, we have the preservation. The trap and seal maintain the hydrocarbon accumulation over millions of years without significant leakage. And then let's look at the importance of petroleum systems in drilling. One, it identifies areas likely to contain hydrocarbons. Secondly, it reduces exploration and drilling risk. And then we have, it helps to estimate hydrocarbon volumes and economic potential. It guides well location selection. And lastly, it assists in basin analysis and resource evaluation. Thank you for your time and welcome again for the next lesson.